Introducing the world top speed AC servo direct twin drive CNC turret punch press EM2510NT, more superior than the hydraulic punch press and mechanical punch press. Compared to conventional punching machine, it is double the productivity. Unlike the existing punching machines, incomparable high speed and high precision process is achieved by new functions and its utilizations. Significant running cost reduction is achieved by AC servo drive system. Moreover, in many areas in which AMADA has been working hard for, such as low noise operation, high-level network construction, wide range of systematization, are actualized even at higher level. Realizing the high-speed hit rate, AC servo direct twin drive system is now introduced first in the world. Compared to conventional machine, 500 hits per minute with 1-inch pitch has achieved 2.5 times faster. For example, this part is processed by 4 parts of multiple part punching. It takes 8 minutes 50 seconds by Pegas 357. By EM2510NT, the process time is reduced by half, 4 minutes 29 seconds. For a part with more holes like this, 33 minutes is taken by Pegas 357, 12 minutes is taken by EM2510NT, achieving triple the productivity. It is now capable of taking the last-minute order quickly. Let's compare the cases in applying fine contouring processes. In this fine contouring process, 0.5 mm pitch of precision nibbling process is achieved with 780 hits per minute. Filing operation normally required after nibbling process is now reduced. By using triple track striker, this type of shape can be finished by high speed. 8 minutes 50 seconds taken by Pegas, 6 minutes 28 seconds taken by EM. Number of hit count increases, but the process time reduces. Life of the contouring tool is very long. Also, replaceable punch tip is cost-effective. It only took 31 seconds per part to complete. Processable thickness is up to 1.6 mm for mild steel and 1 mm for stainless steel. It only took 100 seconds per part by using one contouring tool. Special tool required by conventional machine can be replaced by contouring tool. Regardless of the delivery date and the cost of a special tool, complex and unique shape cutting is possible more flexibly at all times. A blank process for a production prototype and the single part production can be completed without using a special tool. Tool changing time is decreased by reducing the number of tools used as a result. Just like the laser, tool assignment is easily done by assigning line software. It only took 100 seconds per part to complete. Another major characteristic of EM2510NT is slug pull protection system. Shown here is a punching process of making a square hole of 7 mm with 4 hits, and 10 mm square hole with 9 hits, by using 5 mm square punch on the vinyl-coated aluminum sheet of 1 mm. With the power vacuum system, slag pull prevention rate is significantly reduced. Strong negative pressure can be created with high volume air. Punched slag is released instantly by negative pressure. Safety inch bend process is able to complete a bending part with small flange. Part is processed by multiple part punching with 2 micro joints and bent downward with inner bar. As shown here, it is bent twice, then separated and collected into the shoot area. Safety inch bend tool used for this process is 2-inch station size. "136 parts of multiple part punching can be completed in 47 minutes and 43 seconds, and it takes 21 seconds for each part. Small flange bend, which is difficult to touch the back edge on the press brake, is now able to bend safely. Punch tip of this tool is replaceable depending on the bending length. Maximum processable thickness is 1.6 mm. Maximum bend length is 30 mm. Flange length can be set for minimum 2 mm to maximum 35 mm. "736 parts of multiple part punching can be completed by 2.2 seconds per part. Variable size and shape of forming process can be realized by using progressive forming tool and ribbing tool in high speed. In this case, progressive offset process is applied for 780 hits per minute with 1 mm pitch. Selected dimension is automatically processed by progressive forming. This is the progressive forming tool. Progressive offset processing of 40 mm is completed in 3.2 seconds. By using auto-index station, any shape of progressive forming is possible as well. Shown here is R-shaped ribbing process. Progressive forming tool is used here. It is completed. Progressive burring process is applied. This is a flange forming of 5 mm height. This tool is capable of forming a straight line and R shape. Profile is being cut and completed. Now it's done. When slotting process is applied, overlap marks appear and the manual filing is required. This new auto-index slotting process makes no overlap marks. By using auto-index station, it makes possible to process profile for any angle. In this demonstration, 2-inch station size of slotting tool is used. Just like shown here, the cutting edge shows no overlap marks. It takes 60 seconds to complete this one part in this process. In conventional method, small parts are processed by multiple part punching using micro joints, and removal process is done manually. Tool used here is for 3.5-inch station. Both punch and die are tip replaceable. Multiple punched parts are separated by 5 mm square punch and dropped by work pusher pin from the die shooter. (31.2 seconds per part is taken for blanking and collecting. EM2510NT makes marking process possible for 1800 hits per minute. Marking parts numbered saves time in sorting process in next process or assembly. Also, this can be applied for indicating the bending and welding positioning. In this demonstration, 12 minutes 49 seconds is taken for Pega 357 with no marking, whereas EM2510NT completes the same process with 216 characters in 10 minutes 53 seconds. The energy produced during RAM deceleration is conserved and recycled for RAM acceleration. This energy-saving system levels out of power consumption. World highest productivity is achieved by its economical and maintenance-free features. Power consumption of Pega while idling is 2.2 kilowatt. EM2510NT is less than half of that, and it's 1 kilowatt. Power consumption during the punching is very low at 5 kilowatt on the average. This is the running cost comparison of this part for each machine type. Running cost, which includes the consumption such as hydraulic oil, is 1/2 to 1/4 of the conventional machine. With the power vacuum system, punch penetration is reduced from 2.5 mm to 1 mm. This also makes the tool life longer. In EM2510NT, RAM speed is controlled for reducing punching noise. Noise comparison of Pega and EM. This is 2.3 mm mild steel. The tool is 10 by 110 rectangular. 92 decibel on Pega, 78 decibel on EM. EM is a working environment-friendly, low-noise machine. Now, let's check other noises of different type of work. This is 3.2 mm mild steel. The profile is being cut using 10 by 110 rectangular punch. It is 83.8 decibel. Process for 2 mm stainless steel. The profile is being cut using 10 by 110 rectangular punch. It is 84 decibel. Also, network control system, CPC, is adopted. Not only having to realize networking with AP100 relay, also virtual prototype simulation promotes an offline work setup and improved machine runtime at the shop. Systematization is also realized. System construction with the peripherals, such as cycle loader with micro-joint cutter and rear side manipulator, is now possible. Quiet, high productive, unmanned operation during night hour is possible. AMADA's new turret punch press EM2510NT has achieved energy-saving capability overwhelmingly and has improved the productivity dynamically. By realizing 7 punching innovations, EM2510NT integrates the other process and reduces the setup at the same time for promoting the revolution of the 21st century sheet metal industry. AMADA joins with customers and offers creativity in technology for making the futuristic manufacture industry.